Hello everyone. Sorry for the listeners. So, this is technical issue. Okay, so I have uploaded a video on the definition of limit, that is the epsilon-delta definition of the limit. I also uploaded two videos on absolute value function, so you can check them out. So they will help you to understand this particular topic very well. Okay. So, let me welcome everybody. Welcome back to another session of this class. So, we'll be discussing limits of functions. So, in the last class, we discussed the definition of a limit informally and looked into the properties of um, limits of functions and functions like polynomial, um, trigonometric functions, geometric functions, exponential functions, and some other class like that. Okay, so today we'll discuss the formal definition of the limit and evaluate the limits of and prove the limits of some functions. Okay, so today we're going to look into linear, quadratic, and cubic functions. So next week, at the same time, we're going to look into rational functions, square roots, and then cubic functions like that. Okay. So just for today, we're going to discuss the definition of limits, that is the epsilon-delta definition of limits of a function. Then we'll look into how we can use this definition, that is the epsilon-delta, to prove that the given limits of a linear function, a quadratic function, and a cubic function. Okay, so you already know that okay, so you already know that the limit of a function, okay, is what you are getting close to. So that is just the informal way of defining the limit. So today we're going to look into the formal way of defining it, and it is the precise way of defining the function as a limit. And we're going to use this to solve some questions. Okay, so pay attention as we dive into this. So now let's discuss the epsilon-delta definition shortly. So this is the epsilon-delta definition of limit of a function. Let the function f of x be defined on the open interval around a. Okay, so please we need to mark some things here. So f of x, take note of that. Then open interval around a, except possibly at a itself. So that is excluding a. Okay, so if the function f of x is defined around the open interval of a, okay, so we can now say that this the limit of f of x as x approaches a, okay, is equal to that's the limit. If and only if, okay, then we have the condition. So this is where students get somehow confused or terrified, so to say. But it's very simple. I will try to break it down for you in the simplest form. Okay. So for every epsilon greater than 0, that is, if epsilon is positive, so automatically there should exist a delta value that is also positive. Okay, such that whenever b, okay, I'm going to tell you the meaning of this as you proceed, is greater than 0, okay, but and less than delta, okay, so automatically it follows that this exists. That is, the absolute value of f of x and the limit must be less than epsilon. So the most challenging part of it are just the most challenging part are just this one here and this one over here. So I will try my best to break it down for you to the simplest way you could understand it. Okay. understand the epsilon-delta definition very well, then it is very difficult for you to prove that the given value of a limit is actually the limit of that function. Okay, so having said it, let's analyze the behavior of the function f of x at a. Okay, so let's see, start the somehow let's say you have the y axis and the x axis at least. Okay, so if you have a point A, okay, so uh, let's use what we are trying to do is the behavior, okay, of this function. Let's say the function is f of x over here. So the behavior of this function f of x around this A. So it could be from the left, okay, like this, and it could be from the right, like this, okay. So and this will be an open interval. So an open interval will be the starting point over here and the ending point over here. Okay. And if you look at this very well, so this can form a circle if I bring them together. So we can say that from here to here, the distance from here from point A to this place is radius, and distance from here to this place is also radius. That is, you can call this one radius, you can call this one radius because they are equal distance from point A. Okay. So you see that this function, okay, must not necessarily be defined as A. That is, if f of x is not defined as A, you can still proceed to get the limit of this function as it approaches A. Okay, so it is not compulsory, okay, that the function must be defined, okay, as A as it said there. So take for instance, you could have something like let's say 1 over x minus 2. So let's say this is f of x for instance, okay. So you see that when x equals to 2, so this function will be undefined, okay. So despite the fact that it is undefined as x equals to 2, you can still proceed to get the limit as x approaches 2, okay. So that is the first statement here. So if the most important thing is that this function must be defined around this open interval, okay? So not necessarily A. So if it is defined as A, so there's no problem. You can still get to the limit C, okay? So in this case, what will happen? If the function is defined at a given point, okay? So the limit and the value of that function at the given point will be equal. Okay, but if the function is not defined at a given point, then the value of the limit, or the limit value and the function value, okay, at that point, okay, will be different. So that is just what it is taking it. Okay, so it doesn't really matter if the function is defined or not at the given point. So we are done with this part now, so we know what this talking about. Okay, so this is the open interval located on the x-axis here. Okay, fine. So we say that the limit of f of x as x approaches A, or the limit as x approaches A of f of x, so we can use either of the two ways, okay, is equal to L, okay. So that is the placement we discussed last week informally. That is, if you are moving closer, getting closer to A, either from the left or from the right, okay, so you'll be getting closer to the limit, okay, of the function, either from here or from here. So that is the informal definition, okay, informal way of defining it. So for every epsilon greater than 0, okay, so this is a universal existence, okay, so this is universal quantifier, okay, this is universal quantifier, okay, so there exists, so if this is positive, so it is a must for delta, okay, so the positive, okay, if this is positive, then automatically the delta value must also be be a delta value. Okay, so let's look into this diagram here. If a is here and we want to find the limit of a given function as a given as x approaches something, maybe 1, 2, 3. Okay, so what we are trying to do is to get the region where the point will be in this open interval. So it could be here, or here. It could be anywhere here. So that is what we are trying to do. So automatically, you can say that this one will give you the closeness. Okay, you can say it will give you the closeness. Okay, to what? To point A. So that is what you can say. You give it the closeness to point A. So that is what it's going to tell you. So you can see that when we said that the closer you move to the given point, okay, so informally, so formally, this is how you say that. So this is the closeness, okay, to point A, either from the left or from the right, okay. So this absolute value will take care of these two. So if you are coming here, so you get the same answer as if you are coming here, okay. So this is it. Now, it will be less than delta. So what will be the delta? Delta is um, how how far you need to be. So let's explain delta now. So okay, let's use this as our delta now. Let's get to the delta from this diagram. So if this is point A, okay, so the radius here, okay, so will be the delta because delta is the how far you need to go, okay, on the x-axis, okay, to get close to epsilon on the y-axis, okay. So that is the delta. So let me just write down here. So it's just like how far you need to go, how far you need to go on the x-axis, so something like this, and epsilon, okay, will be how far you need to go along the y-axis, okay, and the y-axis, okay. So that is from the given point. That's just the standing. So you can see that from point A, okay, to the open interval here. So how far do you need to go? So that will be your delta value. So I can write instead of radius here. So I can write delta here. So this is the delta that is from this port to this port here. So that is delta. Okay. So how far you need to go from the open interval to the given point A. Okay, so equally you can do the same thing here. So how far you need to go from here, okay, to this place is also delta. So this is it. I can move this onto so radius, I can write the value of delta here. So this is delta, this is delta. So now you know that delta is how far you need to go, okay, from the open interval, okay, to A, so that is delta. So if that is the case, then this particular point, so let me call this, it will be A plus delta, okay. So I'm just trying to explain everything to you so for you to understand. This will be A minus delta, okay, so this particular point here. So now the epsilon will be the corresponding value, okay, from your delta. So I think I can extend this a little bit. So if I take this up a little bit now, this is the one, okay, then this one, and this, we are coming here now. So this will be epsilon, okay, so this delta, okay, any value of delta, okay, will produce the value of epsilon here, okay. So this will be epsilon here too. So let's say we are coming from this point here. So we're also coming from this point here. Okay, so this point now, okay, and I can instead of f of x, I can put the limit here now, L. So this will be L minus epsilon, and this force will be L less epsilon. Okay, so that is what we need to take note here. Okay, so I've explained the epsilon, I've explained the um, delta, okay, and I've explained the meaning of this. So this x, okay, I can manage this. So this value, absolute value of x minus a, okay, so it is the closeness, okay, to point A, as I said earlier, okay, I think I it here. So why this is the closeness, right? Closeness to, I'm gonna take this to point A, and this one will be closeness to the limit. So if you say that x, the absolute value of x minus a, if you say that this one now, the absolute value of x minus a, okay, must be greater than 0 and must be less than the delta value. So what this one means, don't forget this one means the closeness to the given from A. Okay, so everything here now means the closeness to the given point A must be within delta, must be within the delta value. Okay, so that means the closeness you want to get to A, okay, must still be within the value of delta. So that is what it means. It could be any of these lines and this diagram. It could be any of these lines here. So that is what it's saying. So this one is like the closeness, and this one, everything now is telling me that the closeness must be within the delta value. Also, slow down a little bit. So, okay, if you have this one now, the f of x minus L. So I said this is like the closeness to the limit. Okay, if it's less than epsilon now, it means it is within the value of the epsilon. So that means it's telling you that the closeness along the closeness to the limit must be within this region or this region. Okay, so from this explanation, you can say that what these two statements is saying, the last two statements from this definition is that tell me how close you need to be here, how close you need to be to the limit, okay? Then I will tell you how close you must be to the given point. So I don't know if you are getting my point. So what these two statements, okay? I can write it later here. So we said 0 is less than the absolute value of x minus a, okay, and it's less than the value of your delta, okay, and we also say that 0 must be less than f of x minus the limit, okay, and it must be less than the epsilon, okay. So what these two statements, this one is dealing with the x-axis, okay, the x-axis. Okay, this one is dealing with the y-axis. Okay, because this is the closeness to the given point, and this is the closeness to the given point, and this is the closeness to the limit. So what this one is saying is this. Okay, so we have the limit here. Okay, so what these two statements are saying. So let me start with, let me call this one 1, and this one 2. Let me start with 2. 2 is telling you is asking you how close do you want to be to the limit? How close do you want to be to the limit? That is what the then I will tell you how close you must be. How close you must be to the given point. Okay, so it's like you're having f of x minus l here, the absolute value, okay, here, and you're having the absolute value of x minus a here, okay. So this one is telling you that how close do you want to be? It's asking. It's like this one is asking. It's like this one is like question, okay, so to say, and this one is like the response. The response. Okay. So it's telling you how close do you want to be to the limit. Then I will tell you how close you must be to the given point. So that is just the meaning of the last two statements here. Okay. So uh, I think I have explained all the parameters in this formula and this definition. Rather. Okay. So here you can say that for every that limit to for every limit to exist for every epsilon greater than zero, okay, so there exists a delta that is also greater than zero, okay, so such that if the closeness, okay, if the closeness to the given point exists, okay, that is such that if zero is less than the absolute value of x minus a and is within the delta value. So this is the closeness to the given point and it is within the delta region. That is, so delta is here. So delta is here and delta is here. Okay, so this is from here. So if this is true, okay, that is, we are able to get the value of delta. So automatically, okay, you must get the limit, the closeness to the limit. So if this is true, then the absolute zero will be less than the absolute value of f of x minus the limit, and it will be less than epsilon. So if this one is true, this is the closeness you must be to the given point, then this will be true. It will give you the closeness to the limit. Okay? So it will give you the function, the limit, the value of the limit. So please take note of this. The closeness here, okay, will tell you the closeness here. So don't forget, once you remember this statement, tell me how close you want to be here, then I will tell you the closeness you must be here. So in summary, once you know the value of your delta, you are done. So because you definitely get the limit. And because here, look at the equation here. Let me revert this. So from here, if epsilon is positive, automatically delta will be positive. Okay. Such that if this one is true, it follows. So it is automatic that this will be true. So if you want to prove any given limit, once you know the delta value, then you are done. Then you need to get the value of this limit. Okay. So let's move into an example. So if you have any question, so you can comment. Okay, and put you can leave your comment here. Okay, then I will respond to you. So let's move into the first example. So prove that the limit as x approaches 2 of 3x plus 1 is equal to 7. Okay, so to prove this now, so you need to state the necessary conditions because in the exam, so the lecturer, so they ask you to prove this. So don't just write. So what you need to do, you need to write the conditions first, then you start the proving. Okay. So unlike the first statement, the first part of the statement that is for every, denotes for every, okay, epsilon greater than 0, so there exists delta that is also greater than 0. Okay, so such that 0 is less than the absolute value of x minus a, and this is also less than the value of your delta. So it follows that the absolute value of f of x minus the limit must also be less than epsilon. Okay, must be less than epsilon. Okay, so now from the given question now, so we see that the value of a is equal to, so let's write here, the value of a is equal to c, is capital C, okay, a is capital A is C, then the limit L is equal to 7, and f of x, okay, is equal to 3x add 1. Okay, so now to prove this, what we're trying to do is to tell ourselves that, okay, we need to, how close do we need, we want to be on the x axis, okay, then this will tell us how close we must be on the x axis. So that means we're going to start with this, okay, and from here we'll be able to get the value of our delta. So once we get the value of our delta, then we are done with part one. And some lecturers are okay with that. When we get the value of the delta, okay, we are done. But some lecturers will want you to check the value of the delta, whether we're going to get epsilon, whether your value, whether the epsilon value is less than, whether the closeness here will be less than epsilon. So that is the second part. Okay, but let's take it step by step. So the first step is to start from here. Okay, so starting from the absolute value of f of x minus L less than epsilon. Okay, so our f of x is this, that is 3x add 1, the absolute value of this is less than epsilon minus limit. So the limit is 7, so minus the limit is less than epsilon. Okay, so let's simplify the expression in the absolute value. Okay, so that would be the absolute value of 3x plus 1 minus 7, that would be minus 6. Okay, so less than the epsilon. So you can factor out 2 to the absolute value of 2 into x minus 3. Okay, so it's less than epsilon. Okay, you can see that this looks like this particular one. Okay, let me just divert a little bit. So you can see that we have some, okay, let's wait a little bit for you to understand. So let's simplify it further. Okay, so from here, I need that, okay, if you have the absolute value of a times b, you can actually split them into the absolute value of a multiplied by the absolute value of b. Okay, so I can do the same thing here now. Okay, so I can say this is the same as the absolute value of p times the absolute value of x minus 3 now. So it must be less than epsilon, and the absolute value of q, okay, is 2. Okay, so in case you have some challenges with absolute value functions, so you can check my channel, my YouTube channel. So our previous two videos regarding this, and I'm very sure that it will be very simple and easy for you. Okay, so times x minus 3 less than epsilon. Okay, good. Now, so if you remember this, now you are trying to get close. You want to tell, okay, how close you want to be to the limit. This is what this is telling us. Don't forget that the starting point is here. And I told you from my inspiration that it's telling you the closeness to the limit. Okay, so we are just simplifying the closeness to the limit. So it implies this, it implies this, it implies this. So that is the first one. So that means if you see this one, that implies the next one, and so on and so forth. So it implies this. Okay, it implies this. So this is saying the absolute value of f of x minus limit has on the to be given point. Okay, so to to do that, you need to do this. So remember that we have the absolute value of x minus a, which is less than delta. So you see that we have x minus a. The value of our a, according to this, is 2. That means we are having the absolute value of x minus 2 to be less than delta. So if you look at this, so let me call this 1 and let me call this 2. If you look at 1 and 2, you see that, oh, sorry, I think I made a mistake here. Sorry. This is 3 here, so I can factor out 3. Sorry. So, okay, so 3 to be here, then 2 to be here. So sorry for that. Then this will be 2. I was carried away. Okay, so we factor out 3 rather. I said 3, then this will be okay. Sorry for that. Okay, so now, if you look at, so this will be 2 here. So if you look at 1 and 2 now, you will see similarity there. S minus 2, the absolute value of S minus 2 here, and the absolute value of S minus 2 here. This is similarity, okay? And this one is less than delta, okay? Right? So we can actually simplify this further, okay? So we can simplify this a little bit so that we have the absolute value of S minus 2 to be less than epsilon over 2. So now you can compare 2 and let me call this one 3 now. Okay, because I don't want to use this. Okay, so if you look at 2 and 3, by comparison, if you compare them, okay, you see that this is actually the value of our delta because they are the same by comparison. Okay, so that means I can say my delta is equal to epsilon over 2. So once you get the value of delta, so we are cool. We are good with the proof. Okay, so that means we are done with the proof. Okay, so but some lecturers will still want to, because why should we be done? So because here, let me illustrate something here. So you have the given point now, P. So you have the open interval around this P. Okay, so now don't forget that from here to here is the value of your delta. So from here to here to be the value of your delta as well. So and I told you that this one is automatic. Once you have the point here, automatically so you get displacement to the limit. It's automatic. Okay. So and that is what this statement is telling you is if 0 is less than the absolute value of x minus a, okay, and it's within the delta region or value, it follows that is compulsory that this limit must exist. The f of x minus l must be less than 7, must be less than epsilon. So you see, if this one is 2, if this one exists, okay, then automatically this will exist. Now we've got the value of our delta, okay, so which is b epsilon over 2. Automatically, so we'll get the limit automatically. Okay, so that is what we're saying. So now to so we're done with the part 1, and as I said earlier, some lecturers are okay with this, and we stop here, some lecturers are okay. But some still want you to test or use the value of the delta. So let's see if this expression, you want to get this to be less than epsilon. Okay, so that is the only thing you need to do next. Okay, so in this case now, what we just do is to write this again. So this is the most important thing. F of x minus l is less than epsilon. So this is like we are starting the part 2 now, kind of. Okay, so just for you to know that we are starting something again. Now, don't forget that this one has been simplified to this. Let me show you. Okay, sorry, I forgot to change to here. A to be here and A to be here. Okay, you can see that the whole expression has been simplified into this. Okay, so that is, let's come down a little bit. So you see that this particular expression is the same as 3 into the absolute value of x minus 2. Okay, so it's the same as this. Okay, so it's less than epsilon. Okay, so now instead of using epsilon now, so what I want to do is that I will try to bring in the value of my delta. So the value of my delta is this. So it's just like I want to do this. So let me write something here. This is 2. So if the absolute value of x minus 2 is less than delta, so it means that the absolute value of 3 3 times the absolute value of x minus 2 will be less than 3 delta. So that is the meaning. Okay. So if I have this now, so instead of writing epsilon now, so I can just say that I can move this one. I say that this is uh, less than 3 delta. So that's what I'm saying. Okay. So because from here x minus 2 so is less than delta, then x minus 3 is less than delta. So this is the same as x minus a and it's less than delta. So it follows that 3 times this will be less than 3 times delta. Okay. So it implies that 3 into x minus 2, that is value, will be less than 3 times. So what is the value of our delta? So the value of our delta is epsilon over 7 is going to be over 3 now, over 70, because we divide by 3. So this will be over 3. I don't think that this is like this. Sorry for the mistake. Okay. So 3 times delta is actually delta is epsilon over 3 now. Okay. So we're going to put this times epsilon over 3. Okay. So that's what it is. So you can see that this will cancel out this and will be left with, so this implies that 2 okay, is x minus 2 is less than epsilon. And again, what does this represent? This is your absolute value of f of x minus l. So we simplify this to this. So I'm bringing it back now. It's less than epsilon. Okay, so we are done. It has been proven. So that's it. So as I said, some lecturers want to see this. Okay, while some lecturers who wanted to use the value of your delta. Okay, and etc. So here you can see that we choose delta. You can see that because delta can be any value here, any one here. So you can see that we choose delta to be equal to epsilon over 3. Okay, okay. So in case you want to try, so you can use this as your practice. Okay, and here what you just have to do is the same step. You have to follow all the steps. So you have to start with the condition. Let me just give you the issue. So for every epsilon greater than 0, so there exists delta that is also greater than 0. Okay, such that 0 is less than the closeness to A. Okay, and then is less than the delta value. Okay, it follows that this implies that the absolute value of the f of x minus the limit, that's the closeness to the limit, is within the epsilon. Okay, so that is what we're saying. And here we just write the value of your a is 1, l equals 2, then f of x is equal to 5x minus 2. So what we need to do is just to start with the absolute value of f of x, then minus l, okay, is less than epsilon. So if you like, you can firstly simplify this, or if you like, you can just substitute and simplify. So this will be like 5x minus 2, then minus l, this is 3, then minus less than the epsilon. Okay, so if you simplify this will give you 5x minus 5. Okay, so it will be less than the epsilon. Okay, so you can factor out 5. can just say that, let me just, and just say that the modulus of AB, you don't need to write this, okay? It's something like, sorry, the absolute value of AB is the same as the absolute value of A and the absolute value of C. You don't need to write it, and just so that you know that this is the absolute value of 5 times the absolute value of x minus 1, okay? So it's less than b. So you now have 5 into the absolute value of x minus 1, which is less than epsilon. So you divide both sides by 5. So the absolute value of x minus 1 will be less than epsilon over 5. Okay? So if you compare this, okay, so I can call this 1, okay? Then you now write this x minus 2 is less than delta. Okay, I call this one. So don't forget that the value of our A is 1. Okay, and this is now. So that is why we're having x minus 1. Okay, so we can say by comparison, so consider that delta is equal to epsilon over 5. Okay, so we can now write which is, okay, write which is delta to be equal to epsilon over 5. Okay, so as I told you, once you do this and measurements are okay, so you get your full mark. One time, want you to do the part 2, and the part 2 will be for you to actually use the value of this delta. Okay, so and that part 2 is simple. Just have to write something like this. Okay? So let's just write part 2. You don't need to write part 2. I'm just trying to tell you that here, so write this one, you are done for some measurements. Okay, but the time we want to use it. So what you just have to do is to rewrite that statement again. The absolute value of f of x minus l, okay, is less than epsilon. Okay, and this one, this particular statement has been simplified to this particular one here, 5 into 5. Okay, so you can write. And if you want, you just use this one directly. But just for you to see how we're going to bring in the value of data. So just for you to write 5 into x minus 1, the absolute value of it is less than what? Less than this. Okay? So we cannot do the rest work here like this. But if the absolute value of x minus 2 is less than delta, okay, then what will be the value of 5 times the absolute value of x minus 2, so it will be less than 5 times of it as well. Okay, so that is the limit. Okay, so that means I can say that this one is less than 5 delta. So instead of writing this one here, so I can now write this one because they are the same, and this is the one I need. But I just use this one to show you how I'm going to write 5 delta here. Okay, so I'm going to write 5 delta. Okay, so this one will now be the absolute value of f of x minus 5. Okay, so it's less than 5 delta. Okay, so now we've got the comparison. This is the comparison model. So we show the value of delta to be epsilon over 5. So we can now substitute. So it implies that we have to look at this. So the absolute value of f of x minus 5 is less than 5 times epsilon over 5. So this is something good. And we are showing that the absolute value of f of x minus 5 is less than epsilon. So it is a must. Once you are able to get the value of your delta here, okay, so once you are able to get the value of the delta here, so you be able to get the limit. So the second statement follows. So you can now say from here now. So this is not okay. So you can just start with some questions. It's very simple. So anytime you are asked to show the limit of a linear function is equal to something like this, you just have to do it in the same way. So you have to do it in the same way. So you just do this like this. Okay? go to the next one. So it's going to be quadratic now. So see the same step. So you see that for every epsilon greater than 0, so there exists value of delta that is greater than 0, okay, such that um, the closeness to some A is greater than 0, okay, and it's less than delta. So it's written like this. So once you can record it like that, you need to memorize. So I'm trying to say that, okay, the closeness, okay, to some A is greater than 0. So that means this one is greater than 0, very greater than this, and this is less than delta, okay. So that the closeness to A is greater than 0, but is less than delta. So when this one is 2, so it implies that the absolute value of f of x minus the limit, okay, must be less than, okay, and be less than epsilon. It must. Once this one is 2, this one must follow, okay. So now from the video question, now we can get our parameters. So the value of A is equal to 1, then the value of L, the limit, is equal to 2, and this is now our f of x is a quadratic function. X squared, okay, yeah, 2x. Okay, so using this f of x minus L less than epsilon, okay, so we can now substitute, okay, so it implies that the f of x now is x squared plus 2x minus I. The value of L is 3, and it must be less than epsilon. Okay, so now we need to prove this. So we need to simplify this. Okay, to get to something like, because our target is to always get something like x minus a less than delta. That's our target. And in this case, it will be the absolute value of x minus 1, okay, less than delta, because this is very key. This particular one is very key. Our key, okay? So let me just do this now. So the next thing we need to do is to factorize this. So how do we factorize this? This is quadratic factorial, okay? So you can factorize this. So we are writing, I want to believe everyone knows how to do this. It will be x squared plus 3x minus 4, 3x minus x minus 3 is less than epsilon. So I can actually rewrite this because I want x squared to be x squared. So x squared minus x plus 3x minus 3. So that 3x to be 3 and it will be easier for me. So it implies that, so I can factor this now, x into x minus 1, then plus 3 into x minus 1, okay, less than 3. Okay, so I can see, I'm still simplifying that. So it implies that x plus 3, okay, into x minus 1, so that is how to factor that, is less than the epsilon. And if you recall again that the absolute value of A times B is the same as absolute value of A times the absolute value of B. Okay, if you recall that, equal to the absolute value of B. So I can do the same thing here. It implies that the absolute value of x plus 3, okay, multiply the absolute value of x minus 1 and less than epsilon, okay. And don't forget that this one, we know that this one is less than delta, right? Because this is our x minus 3 and it's less than delta. So this is our x. So the only one here is this. So this one is giving us balance. You know, if it to be let's say something like 2 into x minus 1, then less than epsilon. So for this one, we just divide this by 2, function will depend on what the value of x, and which you don't want to your delta sorry your delta will depend on the value of x, so which you don't want to happen. Okay, so that is why you have to find a way of doing this. You can see that from the beginning up to this moment, so I did the same thing I did when I was proving the limit of a linear function. Okay, so here now there is a method that we need to deploy now. Okay, so let me show you this. Currently, if you have point, this is our point, this is 1. So let's say we have an open interval around this 1. Okay, so now we just want to take the unit step to our x minus 1. So our x minus 1 here will be in this region, from here to here. Okay, so it will be from here to here. That's our x minus 1. Don't forget that x minus 1 is less than delta, and this region is for delta. Okay, so if you take a step towards 1, that is, you take a unit step towards 1, okay, so that means that this x minus 1, the absolute value of x minus 1 will be less than 1. So don't forget that if you are taking a step closer to something, okay, so that something will always be less than that thing that the step you are taking. So now, so I'll just write that because this is how I can get the value of x. Okay, so taking a unit step, okay, taking a unit step to the absolute value of x minus 1. Okay, that's what we want to do now. So, and I've explained to you, so this x, so the absolute value of x minus 1 will be less than 1. Okay, so because we are taking a step towards it, so that means it will be less than 1. That is the implication. Okay, so that means the distance from the second interval to 1 is more than 3. Okay, so that is what we are trying to tell you. Okay, so in Canada, since you're taking a step, a unit step to b, then we can say that this x minus 1 is less than 1. Okay, so you can use any number, you can use 0.5, you can use, but 1 is easier, so that's why I'm using 1. So it could be any value. Okay, so from here now, what is the meaning of this? Okay, so I need to explain something for those who don't really understand how to split absolute value of a function. Okay, so before using the direct method. So if you have something like this, if you have the, and that was the reason I said from the beginning, from the introduction, I said you can see those videos. Since you are here, I think the best thing is just to give you a quick revision. So the absolute value of A, okay, equals to B, simply means two things. So A is equals to B, or minus A is equals to B. So that is what it means. Okay, and if you have this in form of let's say inequality, the absolute value of A, okay, is less than B, for instance. It means minus A is less than B, or sorry, let's start with the positive. A is less than B, or minus A is less than B. Okay, so for this one here, if minus A equals to B, so if you divide both sides by minus, you see that A is equals to minus B. So automatically you're saying that A is equal to B, or A is equal to minus B. Okay, so the same thing here. So you say minus A is less than B, so if you divide both sides by minus 1, negative equality now. When you are dividing by negative sign, so you split the sign, you change the sign. So this is equal to A is greater than minus B. Okay, A is greater than minus B. So which implies that minus B is less than A. Okay, so this is how to do this. So instead of doing it one by one like this, so you can actually combine them to be 1. Since minus B is less than A, so you can say that minus B is less than A and A is less than B. So that is just the direct way of doing it. So from here now, instead of splitting them into two, I just write directly. So the absolute value, I keep on saying absolute modulus, because in vector we have to do that modulus. Okay. So the absolute value of x minus 1 less than 1 is the same as minus 1 is less than x minus 1 and x minus 1 is less than 1. So that is just the ratio using them. Okay, so now I want to get to the value of x, so I can simplify. To get the value of x, so I must add 1 to this. Okay, so I must do the same thing across, add 1. So minus 1, we can see 1 here. That means I'm left with x here. Okay, so minus 1 minus 1, that means I get 0. So I don't need to do that. Okay, 0 is less than x. And this one, 1 add 1, it will be 2. Okay, now, we have two values, okay, that starting from 0 and then less than 2, okay. So we want this to be bigger. Okay, which one am I going to select between these two? Let me show you. If you come here, I want this to be bigger. I want this to be bigger. If I want this to be bigger, so automatically if I select 0, of course, everything will disappear. So 0 is not area. So if I pick 2, okay, so it will make 10. If I put 0, so this will be 0 plus 2, and that will be 3. Okay, so that means it will be 3 times this. Okay, so don't forget I want this to be bigger. If I pick 2, okay, so it will be 2 plus 3, that will be 5, 5 times this. Okay, you can see that picking 2 is better than picking 0 because 0 will make it bigger. Sorry, 2 will make it bigger than 0. So that is why I'm going to pick 2. So note that x is exactly 2, no. So, but x is very close to 2. Okay, so we are going to see what we're going to do. So now I'll show you the reason I'm going to select 2 now. So I will now come back to this place. Let me write this now. X plus 3, I'll come back to this. X plus 3 into x minus 1. So here, so I say x minus x plus 3, yes, x plus 3 into multiplied by x minus 1, okay, is less than epsilon. So we want to combine that. X plus 3, x minus 1. Yes, okay, so now, so since I take x to be 2, so this will be 2 plus 3 and x minus 1 less than epsilon. So I'm not going to substitute here, okay, because I'm just trying to get rid of this one. I know that this one is less than delta. I know. So this one I don't know. Okay, so I want to turn it to the constant. That's what I'm trying to do here. So that this will be absolute value of 5 and the absolute value of x minus 1. Okay, it's less than 0. Okay. So now I think I can clear to you now. So the absolute value of 5 is the actually 5. Just to give you a positive number. So into x minus 1 less than epsilon. You can see that this one is now like what we'll be doing, what we do under the limit when we choose the limit of the function of the linear function. So now I cannot divide both sides by 5 now. So the essence of the essence of showing this, the essence of showing that the absolute value of x minus 1 is less than 1 is to get here. So that is the essence of doing it. To get to this point here. To get here. So now consider the absolute value of x minus 1, okay, is less than epsilon over 5. Okay, so I can call this one 1. Okay, so if you compare this with normal, you know we have this one is like x minus 2. If you compare this one with the absolute value of x minus 2 less than delta, okay, you see that delta is equals to epsilon over 5. Okay, so that means we choose this is one value among the possible values we could choose. So we show that we choose, that's right, we choose delta, we choose delta to be equal to epsilon over 5. Okay, so that is it. Okay, so that is it. So once you get this, you are done with your proof. Okay, so but next class we want you to test it. Okay, because this will automatically give you the value of the limit. Okay, and the value of the limit must be the given value. Okay, so it will automatically give you the value. So this will tell you that the limit of the value of the limit when the delta is epsilon over 5 is 3 as given by the equation. But let's see the part 2. Okay, but this one now, we want to do the part 2 now. You know, for linear function, we still use this. We use f of x minus l less than epsilon. Okay, so this is what we use. Okay, we use this. Okay, so but now we're not going to use this. Okay, why? Because we took a step, we took a step towards x minus 1, the absolute value of x minus 1. Yes, so I mean, yeah, we took a step towards this here now. So that means we are going to use this particular one here. Okay, so because we're taking the step towards that. Okay, so now I think there is something I could have written. Okay, your delta now can be, let me think there's something different. I just remember when I mentioned that the last question that we took a new step to x minus 1, to the absolute value of x minus 1. So it means that our delta, okay, will be between so the delta now, you know how something like 1 against epsilon over 5, okay, because we took a new step towards that x minus a. Okay, and don't forget that this the absolute value of x minus a deals with what? It correlates with delta, the value of delta. Okay, so since we are taking a step towards this now, so it will have impact on delta. So that is why we have to say that okay, delta now, so that you can see that delta now will be the minimum value, okay, between 1 and epsilon over 5. Okay, so you can say this. Okay, so you can choose 1 if you want, and you can choose epsilon over 5 if you want. Okay, but the minimum value is what you have to pick. So that is why you can transform it. Okay, you can say you can have two cases here. It's 1 when 1 is less than. Okay, so let's see the first instance here. Okay, so from here you can just say that that's right, the absolute value of x minus 1, okay, is less than 1. So I think you can still remember where I took this. Because when we take a unit step to x minus 1. So do you still remember that? So if you take a step towards that, so that is what you're going to get. Okay? So now, I said the minimum value. Usually, this number here, okay, used to be smaller than the first number usually. But it's not always. At times, one could be smaller than this. Okay, okay, but usually epsilon over 5 used to be smaller than this. Okay, so and I told you that you can take this one, you can take 1 to be smaller than this, and you can take epsilon over 5 to be smaller than 1. So anyone you take, you still get the same answer. So from here now, so I will say I will let for me I'm saying that now 1 is less than epsilon over 5. So here you have two options. It's either you say, let me take a note here. So it's either you say 1 is less than epsilon over 5, or you say epsilon over 5 is less than 1. So in the first one now, you are saying that 1 is smaller, and in the second one, you are saying that epsilon over 5 is smaller. So anyone you think is okay, you are still going to get your answer, okay? So no problem. So if you're writing the exam, so you can take the two ways by firstly use this, then you use the second one as well. So it's a yes, okay? So, but the most important thing is that you must write this. This is the most, okay? So because we took a step, okay, closer to the absolute value of x minus a, okay? So that is why we have to write this. It's a most, okay? So now, if you do this, so you say, you take 1. So for me now, I want to let 1 to be less than epsilon over 5. So it implies that so we can multiply both sides by 5. It implies that 5 is less than epsilon. Okay. So having written this, I can now go back, okay, to my word. The absolute value of x minus a, okay, so is less than okay, let's say this one. Let's go back to let me write something. There's something I can write for you to understand better. So let's fill up. I see you. So I want to go back to this one now. So this is where we substitute the value of delta. Okay, this one. So just like we did under linear function. So if I write that, well, I think I can write it elsewhere. Okay, for you to understand. So that's what it now. So I can write this first, that the absolute value 5 into x minus 1. Okay, so don't forget, let me write again. The absolute value of x minus 1 is less than delta. Okay, it means 5 times the absolute value of x minus 1 is less than 5 delta. So please, it should be used to this now. Because I'm not be writing this from time to time. Okay, so that means that this one will be less than 5. Okay, so it will be less than 5. Okay, so please, if you have any question, so let me know. Sorry, it will be less than 5. Okay, or sorry, let's use this one. Let's use this one. I want it to be clear because if it is not clear, you will get somehow confused. So that's what I'm to do. So let me use this one. So if you say x minus 1, okay, is less than 1. Okay, so what does it mean? It means 5 times x minus 1, okay, absolute value of x minus 1 is less than what? 5 times 1. So let me use it. So I think it's better to use this here. Okay, so don't forget this one is from the first we took towards the absolute value of x minus 2. Okay, so now if we say this is less than 1, then this one is from our function. So up here, so can you see from here? So this is 5 is the absolute value of x minus 1. Okay, so now it's less than 5 times 1, which is 5. Okay, and one thing is this, we say that 5 is less than epsilon here. Look at it. 5 is less than epsilon. So if this implies this, then it means that 5 into x minus 1, okay, is less than epsilon. Okay, so because 5 is less than epsilon, that is what we establish here. Okay, so it implies that, don't forget that here, the rate of this expression, this particular, this part of this expression here, represents the absolute value of x minus l. So we simplify this into So I'm returning it back now. So must be less than epsilon. So this is the final part of your C. So this has been proven as well. Okay. So that is it. So just like what I told you earlier, anytime you have the value of the delta, in this case, our delta is between this and this. Okay. So and don't forget why you get one is because we keep a step towards this x minus a. So x minus a correlates with delta, even from the definition of limit extension. Okay. So and this could be the smaller one, this could be the smaller one. And as I told you, you can, if you like, instead of you taking from here, I said one is less than this. So if you want, you can say that um, so if you like, you can say epsilon over 5 is less than 1. Okay, so if you cross multiply, so you're still going to have epsilon to be less than 5. Okay, so then try it the other way around. Okay, and see what you're going to add there. Okay, but usually, so the other one is the smaller, this particular one. Okay, so if you try this, if you try this and you are able to get your answer, okay, so that means epsilon over 5 is not less than 1. So it implies that 1 is less than 2. Okay, so that is just the implication. So if you say, if you are using this one now, epsilon over 5 is less than 1, okay, it implies that epsilon is less than 5. So if you come to this expression here now, okay, so if x minus 1, so if the absolute value of x minus 1, so I'm just saying it the second way. So if the absolute value of x minus 1 is less than 1, then up there, so what we are trying to say now is that 5 times the absolute value of this one, okay, will be less than 5, okay? So from here now, you see that 5 is what is greater than epsilon. 5 is greater than epsilon here, okay? So it will not work here. So that is the implication, okay? So it will not work here. So that means this is greater than epsilon, okay? So that is how to do it. Okay, so there's no how to, in case you test one and it does not work out, okay, then you have to try the other one. Okay, so that is just what I want to show you. Okay, so for this one, you need to show you. Okay, so you can try to attempt this. This is for you. Okay, you can try, but let me just give you the issue again. So you have to write the introductory part of it. Okay, that is so for every epsilon greater than 0, I will not use this. I'll just give you the list. So you can set it and use. So here I see the delta, okay, that is greater than 0, such that the distance around A, so the distance around A is written as this, x minus A, the closeness to A rather, okay, is greater than 0, that will be 0 is less than this, it means it's greater than 0, and it's less than delta. So if this is 2, so it follows that, it implies that this will be less than, because let's say of x minus 2 is less than epsilon. So this is equal to from here, the value of your A equals to negative 2 now, then the limit is equals to negative 1, then f of x is equal to x squared plus 4x plus 3. So you have to start using this one. The absolute value of f of x minus L is less than epsilon. Okay, so you cannot substitute the parameters. So this will be x squared plus 4x then L, that is less minus 1 must be less than epsilon. So from here, you can come to this place. It will be x squared plus 4x plus 2. Okay, this is going to be positive. So there is 3 plus 1. So I can see this is 4, then less than epsilon. Okay, so from here now, can I factorize this? I'm almost done with everything for you. Okay, so just the x squared plus 2x plus 2x plus 4. Okay, then less than epsilon. Okay, so from here, let us to separate completely. X into x plus 2 plus 2 into x plus 2. Okay, less than epsilon. You can see that it's easier to do when we are solving without explaining. So, explanation has to be a little bit slower because you just want it to, I want you to understand. So, finally, can just have this now. X plus 2 into x plus 2, okay, less than epsilon. Wow, something interesting is here. Okay, so look at what we have here. So I need you to take it from here, okay, and let's see what you have. Okay, so take it here and finish it. So you need to do something here for you to get to the final answer. So let's go to the last one, and that will be the last part of our lesson today. So what we need to do here is to move into the last one and we call it today. Okay? So now let's move into this one. It's the same step that we need to follow, just like what we have been doing. There's nothing special. Okay? So I'll be a little bit extra. So here I will say that for every epsilon greater than 0, okay, so here is this delta, okay, that is greater than 0, such that the closeness to point A is greater than 0, that is less than delta, okay, okay, so it implies that f of x minus b is less than epsilon. So that is what it's telling us. Okay, so from here, the value of my a is equal to 1. Okay, and the limit is equal to 0, and f of x is equal to x cubed minus 3x plus 2. So as usual, using the absolute value of f of x minus l, okay, so less than epsilon, okay, so it will be, it implies that x cubed minus 3x plus 2 minus plus 2 minus 0 is less than epsilon. So that is what it implies. So, and this one is implies that so it implies that the absolute value of this will be x to the power of 3 minus 3x plus 2 is less than epsilon. So here we have two ways of doing this. Since it approaches minus 1, okay, minus 1, since it's 1, it approaches 1 here, okay, so that means x minus 1 will be a factor. So from here, you can use long division method here to get break this down, and the other method you can use again. So I will show you the method. Sorry, I will show you the method here as well. So I'm 3 divided by 12. So let's start with this. So it's going to use the long division method. Okay, so we're going to have to find the something x to the power of 3 minus 3x plus 2. So I think that x, since x approaches 1, that means x minus 1 will be a factor. So I divide by x minus 1. And from here, x to the power of 3 divided by x, so that will give you x squared times x to give you x cubed, x squared times negative 1 to give you negative x squared. Okay, so if I subtract, this becomes to minus and this becomes to plus. Okay, so this becomes to be, so I'm left with x squared minus 3x. So I write x squared minus 3x. So let's write again, x squared by x, we get x. So x multiplied by x, we have x squared. Then x multiplied by negative 1, we have negative x. So if we subtract again, this becomes to minus, and this becomes to plus. Okay, so this becomes to this. Then we have minus 2x. Then we need to drop 2 to be plus 2. Okay, so let's divide again. So minus 2x divided by x, so this will be minus 2. Minus 2 times x will be minus 2x. Minus 2 times minus 1, that will give you 32. Okay, so here, if you subtract, this becomes to plus, and this becomes to minus. So we have 0. So that means we have x minus 1, okay, into x squared plus x minus 2. Okay, so this is the quadratic expression again. So you can still factorize this again. So by factorizing the method. So I'll just stop here because if you factorize this, so if you get x minus 9 and x plus 2 there. Okay, okay. So you can finish it. So let's say what you do. So from here, so let's factorize. So let's factorize this again. So this will be one factorial quadratic now to be x. So then we're going to have x squared to be minus x plus 2x minus 2. Then from here, I factorize x into x, then minus 1. So then plus 2 into x minus 1. So now this will be x plus 2 into x minus 1. So if we drop this one now, that means the other expression will be x minus 1. So we have x minus 1 repeated. Okay, it will be x. Sorry, let's say that this. So it will be x minus 1 squared into x plus 2. So that is how you can get. Okay, so that is one way of doing it. Another way of doing it is to write this x to the power of 3 minus 3x plus 2. So I'm going to take this into this minus 3x. Okay, I'll take it into 2. 6 into 2, so it will be x cubed. Then I use minus x. Then 2x. Okay, so this is 2 minus 3x. Okay, then plus 2. Okay, so now I can now factor out x here. So this is 2x into x squared, then minus 1. Then I can factor out 2 here, minus 2 into x, then minus 1. Okay, so but this and this, they are not equal. Okay, so this one is the same as difference of 2 squared. So I can write it as x into x squared minus 1 squared including minus 2 into x minus 1. Okay, so I can now write this one as here, difference of 2 squared. So I can now express it together. So it will be x into x minus 1 into x plus 1. Then x minus 2 into x minus 1. Okay, now I have x minus 1 here, x minus 1 here. So I can now say that x into x plus 1 into x minus 1 into x plus 1 into x minus 2 into x minus 1 into x minus 1 into x minus 2 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 into x me take it to the other one. So I have x minus 1 to be common, so I can put x minus 1, okay? Then, into, let's take the outside one, it will be x into x plus 1, then minus 2. Okay, so I can simplify what we have here. I can simplify this. So this will be x minus 1 into x, what will be, it will be x plus, plus x, then minus 2. Okay, so that is what we will do. So we can see that now we arrive here. So this is quadratic expression, and what we do here something is the same. So something like x plus x minus 2. So something from here is the same. So that means this will also be x minus 1. So if we factorize this, we get x minus 1 and x plus 2. So this means we have x minus 1 squared into x plus 2. So this one we have to use long division. Okay, so this one we have to understand the linear. Okay, to do the long division. So you have to do the long division. So other we are doing it. So now I know that this one now I can factorize this to be x minus 1 squared into x plus 2. Okay, this is less than x plus. Okay, I also know that I can split this into 2 as shown with the other point. The absolute value of x minus 1. Okay, let me start with the other one. Let me start with this. The absolute value of x plus 2 times the absolute value of x minus 1 and less than x plus. So you can see that we are now at the common point. So this place is not new to you. You know this step very well. So our challenge here is this. Okay, because you cannot, this, we know that this is less than delta. Okay, but we don't know anything about this, and cannot divide both sides by x plus 2 as usual. So the next thing you need to do, you need to take the step close to this. So taking the unit step to absolute value of x minus 1. So we have the absolute value of x minus 1 is less than 1. The thing that in the previous difference. Okay, so let's go. So now this one is taking as you already know. Sorry, I'm trying to say now. So this here now. According with two cities, so it means minus 1 is less than x minus 1 and x minus 1 is less than 1. So since I want to get to the value of base, I can just add 1. I want to get x, so I'll add 1 here, and add 1 here, and add 1 here. So as I do this, this will give me 0, and 0 will be less than 0 will be less than this and this x, and this will be 2. So this is what I'm going to do. Okay, so just like what we did the other time, so it's pretty easy. So I think you can follow up like that, right? So you know the one you have to select out of the two. So you need to choose y because you want this expression to be bigger. So if you want to substitute 2, I'll make it to be bigger. So you substitute 0, so it is more than when you substitute factor 2. Okay? So now let's do 2 now. Now do this. Alright, this is so by our statement, so therefore this the absolute value of x plus 2 multiplied by the absolute value of x minus 1 x minus 1 squared. Okay, so we by is addressed in here is less than epsilon. So once you get rid of this now, you need the value of x, and you're taking x to be 2 now. Okay, so this will be the absolute value of 2 plus 2, and the absolute value of sorry, you're not substituting for this one, x minus this is delta, okay, x minus 1 squared is less than epsilon. So this will be absolute value of 4, and the absolute value of x minus 1 less than epsilon. Okay, so this is less than epsilon. Sorry, and let's do that. Okay, so you know that the absolute value of 4 is 4. Is 4 is the absolute value of x minus 1 squared. Okay, so less than epsilon. So already you know how we take care of this, right? So let's divide those sides by 4 because this is a constant now. So this will be the absolute value of x minus 1 squared. Okay, so it will be less than epsilon is 4. Okay, so there's something you to do here now. You need to take care of both sides because you need to get the absolute value of x minus 1. Okay, without square. Okay, so you take care of both sides. Okay, take care of both sides. Okay, so this will use us to the absolute value of x minus 1. Okay, less than the square root b. Okay, and this will be what implies this. So it implies the absolute value of x minus 1 less than the square root of epsilon over 2. So the square root of 4 is 2. And take square root of 4 and we use the square root of epsilon. So we compare this now with the absolute value of x minus 1. So the absolute value of x minus 1 is less than delta. So you see that delta is the DC. But don't forget that we took a step towards x minus 1. Okay? And we took a step towards the absolute value of x minus 1. Okay, anytime you do this, okay, so the delta will always be equal to the minimum value, okay, between the minimum value of 1 and square root of epsilon over 2. Okay, so we must have the range, okay, of value. Okay, anytime you take a step, so we're taking unit step, yeah, taking a unit step to reduce. So we must always have this minimum of it. So we can set it and please always remember that the value of data is not just to be and when you know that what to do from here, so it's either you say this one is less than b or square root of epsilon over 2 is less than 1. So if you take one and you don't get the answer, then you have to use the other one. But once you use one, okay, and get the answer, so you need to use the one and get the other one. I think that's very based in the previous solution. Okay, so now if you get this, we are already done with the pool. So it's just pool here. But unless I still wanted to at least test the value of each data. We want to test the particular we have to do this one. And it's very easy. So you know what to do. So you just make an assessment that okay, between these two, one is less than the other. process here, I just say let one to be less than b. Okay. So if I take this and it doesn't work out, then I have to come back to let to be less than one. Okay. So that's just so let me do this first. If I get my answer. Okay. So if I let one to be less than b, so it implies that epsilon. So let me multiply this by 2. So it implies that 2 is less than epsilon. I want to get epsilon. So I square both sides so that 4 is less than epsilon. So I use it. Okay, now, so let's go back to where we have this, you know that from here is absolute value of x minus 1, okay, is less than delta. So from here, so this is where we always try to do the step here, okay? So I just say that now, but in this case now, what did I write? I said the absolute value of x minus 1 is less than 1 because I think it's towards the absolute towards this, okay? That's why I'm going to say, but not take any step towards this, so I have to use this one, okay? So for a linear function, okay, this is what we really see, the value of the data. And then we have the quadratic, maybe another one, quadratic, cubic, and another one, so we already see something like this, okay? So because that I use this one, the absolute value of x minus 1 is less than 1 if this is the case. So my f of x now, don't forget that my f of x has been simplified to 4 times the absolute value of x minus 1. This is my f of x here that I simplified. At least you can see that off here. So this is here. So this is my f of x. So if absolute value of x minus 1 is greater than this, then 4 times the absolute value of x minus 1, okay, will be less than 4 times 1. So it means it implies that 4 times the absolute value of x minus 1 is less than 4. First, but it says 4 is less than epsilon. And this, you see? So that means I can say that 4 times x minus 1, the absolute value of x minus 1 is less than epsilon. Since 4 is less than epsilon, that means it is less than epsilon. And we already know that this is the same as our absolute value of f of x minus l because we simplify this to this at the beginning. Okay, so it's less than epsilon. So this is what I guess I have to do. Okay, so here is my one. So please, once we get to this place, we are able to get to the value of the data and the range for the data and to here. Okay, so I think I'm going to here. So we go to the data to the so once we get there, then we are done. Okay, so we keep always do it because we don't know what is one. Okay. So if we do the end of this class today, so at the same time Saturday, we are going to use to we are going to prove the limit of the squaring function could be rational function. We have about 4 of them there. Okay. So again, so just copy and copy this one. Okay. So if you have any question, so you can reach me on my YouTube channel, Analytics. send a direct message to my email address. My email address is available and it is available. So into them, that is this question, and you can also check other questions yourself. And that is this question is the question, correct question. Okay. So, see you